everyone, welcome to InsightsByRish. In today's video, we are going to implement a project of data analysis and visualization where we are going to make use of COVID-19 data. Here we are going to build various charts depending upon which we will try to analyze this COVID-19 data. Now I will be using this particular dataset of COVID-19 from Kaggle. I will provide the link of this dataset in the description box. Here we have various CSV files from which we are going to particularly use the specific one, which is country-wise latest CSV. And I have already loaded that CSV file here in my Google Colab environment, as you can see. So we'll start implementing the project now. First, we will import the libraries. So first I will import pandas here. Now for data visualization, you can either go with matplotlib, Seaborn, or any library you know, but here specifically I am going to make use of plotly library because that gives or that builds many efficient charts for you, which makes it easier for visualizing and analyzing the data. So let me import plotly here. Let's run this. Now we will import the dataset here. Let's name our dataset as COVID DF. Here we will just paste the path of the CSV file. Let me run this. Now after importing the dataset, we will check the dimension of the dataset here. Let me say COVID data frame dot shape. So we have in total 15 columns here and 187 rows. Let me display the dataset for you. Let me say here COVID data frame dot head. I will just display the first 5 rows. So this is the dataset that we have, and these are all the 15 columns that we have. If you closely take a look at every column, you can see we don't have any kind of unwanted columns here. So we don't require to delete any of them. Next, we will check for the null values, because before proceeding to the exploratory data analysis and visualization step, it's also necessary to clean the data and to make the data efficient for analysis. So we'll check for the null values here. Let me say COVID data frame dot isNA dot sum. It will give us the count of null values from every column. So as you can see, everywhere it is just 0, which means no column has any kind of null values. So the data is efficient and we can further use this particular data for visualizing and analyzing the data. Now moving ahead to our core concept of this particular video, which is exploratory data analysis and visualization. This all visualizations we are going to perform into this particular video, and they are slightly advanced, not very basic. So starting with, we will first see which countries have the highest number of confirmed cases, and also we are going to build a different visualization chart for every question here. So the first question is, which countries had the highest number of confirmed cases? So to perform this, we are going to make use of bar plot. Now there are multiple countries here. You don't want the count of confirmed cases from every country. They have just mentioned the highest number of confirmed cases. Now the highest number of confirmed cases, like the countries from which we want to find the countries which had highest number of confirmed cases, can be just top 5, top 10, top 15, anything. We are going to perform this particular for top 10 countries. We will find the top 10 countries with the highest number of confirmed cases here. So for that, we will say COVID data frame. Now here we are going to make use of n largest method. This will give us the top 10. Here you have to provide the parameter, and the parameter 10 basically specifies that we want the top 10 countries. Now you also have to provide the column name based upon which you are going to consider that these are the top 10. So the column name should be confirmed. If you take the look at this data set, you can see here we have a confirmed column which has the count of confirmed cases for every country here. So we want to find the top 10 countries with highest number of confirmed cases, and hence we'll pass this column name here. Fine, let me run this. So as you can see, these are the top 10 countries which are having the highest number of confirmed cases. Now we are going to plot them, and before plotting them, we are going to save them in a variable. Let's name it as high confirmed cases. Let's run that. And now we are going to make use of this particular data frame, high confirmed cases, for the further visualization, because this high confirmed cases data frame now only consists the list of on all the data of top 10 countries which are having the highest number of confirmed cases. So here, to plot the bar plot, we will say px dot bar. ps is an alias given to the plotly library, and bar stands for bar plot. Now first we will pass the data set here, which is high confirmed cases. Then on x-axis you want to display the country name. So if you take the look at this particular data set here, let me just display it. You can see you have all the columns here in the high confirmed cases data set, but you just want to make use of these two columns here. On x-axis you want your country or the region, and on y-axis you have the count of confirmed cases. So on x-axis we will have this. Let me copy it from here and paste it here. And on y-axis we will have the confirmed column, which will demonstrate the count of confirmed cases. And then we can also give a title here. So let the title be top 10 countries with the highest number of confirmed cases. You just have to put that in a single quote. Fine. Let's run this. So as you can see, this is our first visualization. So if you take the look at this particular bar plot, you can see that the United States, US, had the highest number of confirmed cases, followed by Brazil and India. Fine. So these are the top 10 countries that had the highest number of confirmed cases. Fine. So this was our first visualization, and from that we have drawn the conclusion that US was the country that had the highest number of confirmed cases, and these are the top 10 countries. Now the next visualization that we have to perform is what was the distribution of confirmed cases across different WHO regions. If you take the look at this particular data set, you can see there is a column of WHO region. Now WHO, that is the World Health Organization, has basically divided the entire group of countries into different regions, and every region will consist of few countries. Now we want to find that in which particular WHO region the number of confirmed cases were high. Fine. And to do this distribution, we are going to make use of pie chart here. So if you want to check the unique values of WHO regions, you can just say here COVID data frame, and the column name is, I think, WHO regions, and here we will just say unique. Let me check the column name here. It's actually region, not regions. Fine. So these are the 6 regions, 6 WHO regions into which all the countries are divided. Fine. So we want to find that into which particular WHO region there were highest number of confirmed cases, or there were more number of confirmed cases basically. So let me say here px.py. Now in this pie chart, first we'll pass our data frame, which is COVID data frame. Then the values will be the data of confirmed cases. So the confirmed column here. Then the names or the labels to the pie chart will be given as the WHO region. So WHO region. So whatever the WHO region is, that will be given as the label to the pie chart. And after that, we will give the title to the chart. So let me say title, and let's say distribution of confirmed cases across the WHO region. Let's run that. So this is the pie chart. As you can see, the more portion is given to the blue part, and the blue demonstrates the America. That is, this America region had the highest number of confirmed cases, followed by the red portion, which symbolizes Europe, followed by the green portion, which symbolizes Southeast Asia. So the highest number of confirmed cases were in the America portion of WHO region, followed by the Europe portion of the WHO region. Fine. And the least confirmed cases were found in the Western Pacific WHO region, followed by the Africa region. Fine. So this was the pie chart from which we concluded that the highest number of confirmed cases were in which particular WHO region. Then the third analysis that we want to perform here is what were the trends in new cases, new deaths, and new recoveries in each country. Now if you try to understand this question, you want to analyze various things, various multiple things in a single graph here. You want to also analyze the correlation of the new cases with new deaths and along with the new recoveries as well. So you want to correlate all these three aspects. So for that we are going to make use of scatter plot here. So we will say px.scatter. Here we will pass the data frame, which is COVID data frame. Then on x-axis we want the new cases. On x-axis we will have the new cases column. If you take the look at this data set, you have this new cases column here. Then you also have the new deaths column here. Fine. So on x-axis we will have this new cases, and on y-axis we will have this new deaths column. So let me say here new cases, and on y-axis we will have new deaths. Fine. After that you also have to find their correlation with the recovery. You also have to find that okay, there are new cases, new deaths, but how many recoveries are also happening. So to do that we will pass one more attribute here, which is size. Now depending upon the size of circle, or we can say the size of dot that will appear on the scatter plot, we can easily understand that what were the recovery amount of people. So let me say recovery. Actually, I think the column name is not recovery, but it's new recovered. Let me copy it from here. So the size of the circle on the plot will signify the recovery amount or the recovery percentage of people. After that, the color of the dots will symbolize the country of the people they belong to. So let me say country or region. I think the column name is country/region. Fine. Then let's give the title here, and the title is trends in new cases, then new deaths and new recovery. Let's run this. So as you can see, this is the scatter plot. The color of the circle or the color of the dot signifies the country. The size of the circle signifies the recovery percentage, and on x-axis you are having the new cases, and on y-axis you are having the new deaths. If you take the look at these three dots that are here, they are slightly, or you can say comparatively larger as compared to the other dots present in this particular graph. The first graph that you have here, or the first circle that you have here, represents Brazil, where the new cases are around 23k and the deaths are around 600, while the recovery is around 33,000. Fine. Then the circle here represents the country India. The new cases are around 44k, the deaths are around 637, while the recovery is around again 33,000. So if you see the recovery number in both the Brazil as well as in India, they are very similar to each other. There is just a slight difference of around 100 and 150. So the size of the circle for both Brazil and India is quite similar, because there is just a difference of 100 in the recovery percentage, or you can say the recovery number. Then the circle that we have here represents US, which is slightly smaller as compared to the country Brazil and India, because the recovery number in the US is low, around 27k, whereas in the country like Brazil and India it was around 33k. So if you take the look at this particular circle that is representing US, you can see in this US the cases are also high, the deaths are also high, while the recovery is low, which is a dangerous thing. But in the countries like India and Brazil, though the cases were mediocre and the deaths were also mediocre, but the recovery was good. And when you take the look at these small dots, so they are representing a very low amount of recovery here. If you take look at this particular orange dot that I am hovering upon, you can see this country is representing South Africa, or the region is South Africa. The new cases are around 7k, the deaths are around just 298, while the recovery is 9k. So this is a good thing. The recovery amount is greater than the number of cases. Fine. So this is how you are trying to correlate multiple things in a single scatter plot. So this was the third chart. Next, the fourth analysis that we want to perform here is what was the 1 week percentage increase in the confirmed cases for each country. we have to find that in 1 week how much percentage increase happened in each countries, of course, of the confirmed cases. Here we are going to make use of choropleth map. So let me say px dot choropleth. Here I will pass the data frame first, which is COVID DF, then the locations. Now in the locations, we will directly pass our country column that we have here in the data set, which is country and the region. Then the location mode. In this location mode, they will be basically represented using the country names itself. So let me say here country names. Then we have to give the color. Now color will depend upon something. So the depending factor here will be the 1 week percentage increase. Depending upon the 1 week percentage increase in the confirmed cases, the color of the countries will vary. So the color, so let me find that column here. So we are going to make use of this 1 week percentage increase. We copy it from here. Fine. So the color of the country will depend upon this particular column. After that, the hover name. The hover name will be same as the country region. It is whenever you hover upon any country, you can view the name of that particular country. After that, let's give the title to the chart. There is 1 week percentage increase in confirmed cases by country. And then you can also give a theme to your plot. Your choropleth map can have a different theme. So let me give a color theme here. Let me say color continuous scale. Let me say a px dot colors dot sequential. These are just the theme names. If you go to the official documentation of this plotly choropleth map, you can find various scales available there. Dot plasma. Let's run that. So as you can see, you are getting this choropleth map according to 1 week percentage increase in confirmed cases by country. Now to interpret this, what you have to do, you have to take the look at this bar given here. The dark blue color is representing 0% increase in a week, and the yellow color here is symbolizing around a percentage increase of more than 200 in a country. So if you try to find the yellow color on this entire map, you can find it here. Let me zoom it for you. You can find that yellow color on this map at this particular location. So if you hover upon that, you can see that this particular country is Papua New Guinea, where the 1 week percentage increase is around 226%. That's very high. After that, we don't have yellow color anymore in this entire map. Then you have to take the look at other colors. So let us take the look at the pink color here, around somewhere around the pink and maroon color here, which also represents the percentage increase of somewhere between 50 to 100. So if you hover upon that, this country is Zimbabwe, where the percentage increase in a week is of 57. Then you also have some purple color here, and when you hover upon that, the country is Libya, where the percentage increase in a week of confirmed cases is around 42%. Then the purple colors represent the percentage increase somewhere between 0 to 50, while the dark blue countries represent a very low percentage increase in a week, which is good. Fine. So this is how you interpret this particular map. So from this we came to the conclusion that Papua New Guinea had the highest week percentage increase in the confirmed cases, while all other these dark blue countries had the lowest. Then the next analysis that we want to perform here is how do death rates per 100 confirmed cases vary by WHO region. Now what we have to do is we want to find that the ratio of deaths according to per 100 confirmed cases depending upon the WHO region. We are not taking it depending upon the country, but depending upon the WHO region, because we have multiple countries here. If you try to do that, you will have multiple box plots there, because we are going to make use of box plot here, and hence we will try to plot it depending upon the WHO region. Let me say px.box. First we will pass our data frame, which is COVID data frame. Then on x-axis you will have the WHO region column, and on y you will have the column of deaths per 100 cases. I think let me take the look at this data set. and we have this column of deaths per 100 cases, and we are going to make use of this particular there. Let me copy it from here and I will paste it here. After that, let me give the title. Title is not compulsory to any of the chart, it's optional, but it's always a good practice to give title to your chart so that a person who is visualizing the chart can easily understand what is the chart about. Then let me say here, death rates per 100 confirmed cases by WHO region. Let's run that. So we have a box plot here, and on x-axis we are having the WHO regions, and on y-axis we are having the death per 100 cases. So if you take the look, for the Europe region, the deaths per 100 cases were high, where the median is of 3.09, while the lowest is for the Southeast Asia. If you take the look at median of every box plot, you can analyze the deaths per 100 cases easily. So the median for the Europe is higher, which is around 3.09. That is, for every 100 confirmed cases, there were 3 deaths. While the median for the Southeast Asia box plot is very low, of about 0.88. Approximately, we can consider it 1. That is, for every 100 confirmed cases, the death was just of a single person. Followed by the Europe, the highest death rate for per 100 cases were for America, where the median was around 2.91, that is again approximately 3. Fine. So this is how you interpret this particular chart. Now the next analysis that we want to perform here is what was the mortality rate, that is deaths per 100 confirmed cases for each country. Now this is what we performed the WHO region wise. This is what we were trying to say, deaths per 100 cases depending upon the WHO region. Now we want to do the same thing depending upon the country and not about the WHO regions. So here again I will make use of this particular choropleth map which we used here. So let me say here px dot choropleth. Here I will pass the data frame, which is COVID data frame. Then we have again the locations. The locations would again be the country and the region name. So country and region, which is our column in the data frame. Then the location mode. On the location mode, we will have the country names. That is, every country will be labeled as its own country name. Then the color. The color of the country will depend upon the deaths per 100 case. In this particular chart, that is in this particular choropleth chart, the color was depending upon the 1 week percentage increase. That is, the color was changing depending upon the percentage increase of confirmed cases in a week. Now the color here in this particular chart that we are building will change depending upon the deaths per 100 cases. So let me copy the column name from here. After that, we will hover it. So hover name will the same as the country and region. Then let's give the title here. The title is mortality rate per 100 confirmed cases by country. And then again we will give a theme to our choropleth map. If you don't give anything, that's still fine, but let me give it. And here we will give a different scale than what we gave in the previous graph. So let me say here px dot colors dot sequential dot, there we gave the scale of plasma. Here we will give the scale of reds. That is, everything will be in a shade of red. Let's run that. So this is the chart. Now you can see the bar. If you take a look at this particular bar, the deaths per 100 cases, that is the high mortality rate, is demonstrated using the dark deep red color, while the low mortality rate is demonstrated using the white color. And if you take a look at this particular world map, you can see that is the deep red color on the map is shown somewhere here. If you hover upon that, let me zoom it for you. If you hover upon this, you can see the country is Yemen, where the mortality rate per 100 confirmed cases is 28. That is, for every 100 cases, 100 confirmed cases basically, 28 people were dying. Now followed by this particular country, you don't find this deep red color anywhere else, but then if you can find the shade of orange here, which again demonstrates some high mortality rate. So they are France and UK, where the mortality rate is around 15% and 13%, and the areas that consist of very light colors, like you can see this Namibia or Australia, here the death rate is very low. So this was the mortality rate analysis based upon the country. After that, we have to see how many countries are in WHO region. Now, as I said previously, we have 6 unique regions in the World Health Organization, but we also want to understand that in particular in every region of WHO, how many countries are present. So for that, we will make use of bar plot again. Let me first say here COVID data frame, then the WHO region column, and then we will say value counts. Let me reset the index here so that we can visualize it in a data frame format. So as you can see, in the WHO region, here we have the WHO region column and the count of countries present in each WHO region. This is what we are going to visualize using the bar plot. So let me store it in a new data frame. Let's name it as WHO region count. Let's run that. Now we will make use of bar plot here. So px.bar, and here I will pass this data frame WHO region count. Then on x-axis we will have the WHO region, and on y-axis we will have the count. And let's also give the title here. Let's say number of countries in each WHO region. Let's run this. So as you can see, this is the bar plot. On x-axis we are having the names of WHO regions, and on y-axis we are having the count of countries present in each of the region. So the highest number of countries are present in the Europe region of World Health Organization, fine, and the lowest number of countries are present in the Southeast Asia region of the WHO. After that, the last visualization and analysis that we have to perform is we want to build the tree map of COVID-19 confirmed cases by WHO region and country. Now tree map, what it does is it tries to compact multiple aspects of the data in a single chart. So it will also demonstrate the WHO region, it will also demonstrate the country, and it will also demonstrate the confirmed cases in them. Let me make use of tree map here. Let me say px.treemap. Here we will pass the data frame. Then we have to give the path. Now path basically specifies that what will be your major region and what will be your minor region. Now in the broader perspective, the first you want is the WHO region, so WHO region, and in the minor perspective you want the country, so country or region. And this part should actually be in a list format, and hence let me enclose it within the square bracket. Fine. After that, the values. Now the values will be demonstrating the confirmed cases, so confirmed, the column name, and then we will have the title. The title will be same, the tree map of COVID-19 confirmed cases by WHO region and country. Let me paste it here and let's run this. So as you can see, this is the tree map. Now in the broader perspective, in the major perspective, we are having the WHO region. So this entire blue portion is symbolizing America, the red portion is symbolizing Europe, the green Southeast Asia, the purple one the Eastern Mediterranean, orange one the Africa, and the blue one the Western Pacific. Then in the minor perspective we are having the countries. Now all the countries that are falling in the America will be here in this squares. All the countries falling in the Europe region are enclosed in this squares. Then depending upon the size of square, we can analyze the confirmed cases. The higher the size of the square, the more number of confirmed cases, and the lower the size of the square, the less number of confirmed cases. As you can see in the America region, the highest square size is for the US, that is the highest number of confirmed cases are registered in US, while the lowest, or you can see the very small square size, is for the country here, you cannot even see that, which is Cuba. The size of the square for the Cuba is very small, which means very less number of confirmed cases were registered there. Similarly, you can interpret for other regions as well. In Europe, the highest square is for Russia, that is the highest confirmed cases were registered in the Russia country in the Europe region. Fine. And the lowest was for, I think, somewhere here for San Marino, where the confirmed cases are very less. And the same goes for all other regions as well. So this was the implementation of COVID-19 data analysis project, where in every question we tried to implement a different chart. So that's it for the video. Thanks for watching.